Good morning to present here. Today I'm going to present my project presentation on the tile type piezoelectric energy harvester from crustacean cell. This way I'm going to present my presentation. The first part is the introduction part. This here we will discuss about the crustacean cell and what is the uh, wastage of crustacean cell from the fish processing industry and what is physiologic effect and the device fabrication. Next one is the experimental methods. Here we will discuss about the what type of materials we have used and what type of presentation we are going to see, and this is device we can make it. This third one is the resultant discussion board. This will give us more accurate of this our objective of this experiment and objective of this work. Then we will discuss about the detail in this section. Finally we will conclude this work conclusion. This is introduction. Cetium occurs in a variety of organisms in aquatic ecosystem. It is the second most abundant natural polysaccharide after cellulose, and it is present in the crustacean, excretion, insects, and fungi. Till date, the main commercial sources of cetium are serum and crab cells. The crustacean cell industry generates a huge amount of cell-based processing, which usually cause environmental effects. This environmental effect nuisance will affect the environmental pollution. This alternatively, this waste can be utilized as an energy harvesting device applications in different applications. This India statement is the Global in COP 2026 is there. India will meet 50% of this energy recovered from the renewable energy by 2030, and India will take it as a non-fossil energy capacity to 500 gigawatt by 2030 years. Yeah, so keeping the mind the above ambitious targets, one of the alternate and effective method to generate power in a sustainable way is footstep energy generation. The slime and crop cells have the piezoelectric energy property which can be utilized by using piezoelectric tiles that harvest energy from the using footsteps. And there's a power generation in footsteps. This is here, see here the diagram. This is how that how people are working for a footstep. This is one of the most important activities in normal human life is footstepping. It is responsible for generating a large amount of energy as a huge amount of pressure is extracted by the crowd of footpaths. In overcrowded countries like India and China, the potential energy wasted can be recycled into electrical energy using piezoelectric tiles that generate electrical energy using pressure or stress. This will generate the electric energy. Okay, this is the objective of this presentation. First objective is called to design tile type piezoelectric energy harvester from crustacean cell. Second objective is called to develop piezoelectric tiles from the crustacean cell. The third one is to check output performance of piezoelectric tiles from piezoelectric material. And this is a methodology, this is experimental part. What we have done in this is first we have collected from raw material of shrimp and crop cells from nearest fishing harbor or fish processing industry or fish processing market. The first we have done is the normal tape water cleaning. This is using tape water. Then the next we move to the pre-treatment process, that is chemical treatment. This will remove all the minerals and materials. And this is the next process, a demineralization process. Here also remove all the materials whatever it is in the crustacean cells. This final process is a demineralization process. This is very important. This after that we will get the flexible and we finally we will get a flexible and transfer such substrate. This is called the piezoelectric material. This have the piezoelectric property. This will make the device from this piezoelectric tiles. This is the processing of piezoelectric crustacean cells. This is a crop cell, this is serum cell, this is a chemical process. We have done this experiment, this is a rotation type. This finally we will get the transparency and a flexible substrate. This flexible will get up to 360-degree. Okay, this is a device. This is a whatever here is the metal. Down also same metal is there, same area. This is a piezoelectric material. Here, what wherever it's metal is, there is actuaria. It is a 2 into 2 or 4 into 4 or 10 into 10, etc. It depends upon the active is a metal that is called the actuaria. It will generate the electricity. This is a full device. Here, see this anode. This is cathode and this piezoelectric material that is called the piezoelectric devices. Okay, there is a design of piezoelectric tiles. Here we have this bottom of this acrylic plate. This after this foam sheet. That after that this is a piezoelectric devices. We have connected series or parallel to the requirement. Then the here upper portion is also given the foam sheet and the final is acrylic plate. This is a full design of piezoelectric tiles for this device. Configurations. The visual transistor were connected in the series or parallel mode to the conversion circuit, which is a simple rectifier circuit containing diode, capacitor, and connected to the battery to store the power obtained from the piezoelectric material. Finally, we can use it anywhere in this materials. Here is the energy conversion device circuit. This is a, here is a piezoelectric tile. This output of the piezoelectric tiles we will connect in this is a full bridge rectifier circuit. Here's the input port of input is from this visual tiles output, and this from this bridge rectifier output we connected on capacitor, and finally this is a on storage battery. The stored energy can be used in anywhere, any application like mobile charge, LED lamp, and street light. Also we can use it depends upon our the storage capacity we can use for this our experiment. Okay, this is the acrylic plate. This is the bridge rectifier. Bridge rectifier. This is storage battery. Inside is our piece of materials are there. Then we can apply this. Here, see this experimental part. We have done this work in this day, 2 days. The voltage generated and the capacity of the piece of tiles. Here, see this is the voltage is different times because when we are applying the pressure. Okay, this is the designed tiles of piezoelectric material energy harvester. If fitted in our college campus portico, the students and all the teaching and non-teaching faculties working in the area. This is the energy is produced and this is storage battery inside. Is that this stored energy can be used as any mobile charge, LED lamp, and street light. We can use it in any electronic appliances. Okay, this is the resultant discussion. We have done this continuously 20 minutes difference. We have done this result 1 to 3 days, and this is the difference upon our stress and this people working at the time and the weight. This to change this air voltage. Here results of 10 to the experiment correction. 5 days it is a time versus the voltage a different the time days it is the time increases the voltage is increased because of this applying the pressure. Okay, this studies on piezoelectric tiles. This is a day versus voltages. This here you see this is a day 1 to day 5. This day 4 is having a more voltage because of this compression tension of this air. We have this more people are working this piezoelectric tiles. This is a factor affecting the output voltage is a place of implementation, the weight of the person, type of movement, the number of footsteps per day, the tile, there's a fabrication materials due to this to the materials. This is finally this is a conclusion of this work. This we concluded. We utilized the bio waste generated from the seafood industry and the vibration waste storing information from the physical tiles. The designed tile type of physical energy harvested from physical property of process and we concluded from our work that waste tiles have the potential to be used as clean energy roster from humans to foodstuff. This device is ideal for places that receive heavy food traffic such as subway, railway station, airports, university, malls, etc. The measured output voltage will be used in energy conversion device in eco-friendly for daily uses of this our human beings. This is this our conclusion part. This is so. If you have any questions, you can ask. This is final this question answer section. This thank you on and all present here.